Hello student, in this video today we are going to cover how to insert a data at beginning of a linked list. Last PPT we are already covered what are the various type of linked list is present, what are the various operation we have to perform. So in this video we are going to implement how to insert an element at begin of the linked list. So for example, this is our linked list is present. For example, first node address is 100, second node address is 200, third node address is 300. So first node we store the information. If we store the address of second node, then only the connection is established. For example, second node data is 220 and now this node, no connection. If I store the address here, then only the connection is established and we can able to link to this one. So this is the last node. So last node is store the value of null. This is the linked list is present, but how we can able to access? If we have the starting address, then only we can able to access. So in linked list, there is a pointer named as the start, which is going to store the starting address of the linked list. So if we store starting address, then only it can possible to access all the element. So whenever we have to insert an any element or delete an element from the ends of the linked list, unnecessary we have to traverse from first node to the last node. That's why in our program we are going to make a pointer name as the last pointer, which is store the address of last. So this is the basic information we have to know. Wait, there are two pointer is present. The pointer should be points to the starting address as well as the last address. So our objective how to insert a node into the first element. For example, we have to insert this node. Insertion first position means that one node is created, we store the value and make the connection, and here make the connection to this one. Then what happened? Insertion of the node at the first position is over. Another case for here, this is what happened. Element is present. If there is no element present inside the linked list, for example, empty linked list. So whenever there is nothing is present inside the linked list, at that time what happened? Start points to the null value, last point to the null value. So when we want to insert a node at empty linked list, then what happened? We have to create the node, store the value, then start node points to the first node, the newly created last also points to, and this one is the node. So this is the scenario for the empty list. Means this is the now the list contains only one element. So insertion of the node at first position can be classified into two types. First case is when list have all the element present. Second one is the when there is no element present inside the list. We have to go through the algorithm. Allocate the memory by using malloc function. So first we have to create the node. Create the node means some memory we have to allocate. So in C language there is a function called as the malloc function, which is present inside the standard library, which main objective is to allocate as per the user requirements. If the memory allocation is possible, means memory is available, then only it returns the value with starting address of the allocated memory. Otherwise it returns the null value. So second step we have to check whether memory allocation is possible or not. So first, if the memory allocation not possible, simple we have to exit, we cannot insert. Otherwise means memory allocation is done, then we have to store the address of newly created node to a pointer named as the new pointer. So we have to make a pointer named as a new pointer, which is going to store always the newly created node address. Then third case, that is whether the list is empty or not. So we have to check if the list is empty, then what happened? The newly created node we have to make as a starting node as well as the last node. And after making the pointer first and last to that newly created node, we have to store the value and make the next pointer to the null, because it is only one node created, because previously there is no element. Third step, next step, after third step, next step is that linked list is present, data is already present. So now what we have to do, we have to make a start pointer to a temporary pointer variable. because we have to insert into the first position. Make the start pointer into the new node, store the value, and make the new pointer to the reference variable. So this is the algorithm we have to follow. I have already explained. Now we have to go through the program. So this is the program we have to write down. So let's go back to the our programming part. So here, these are the header file we require. I have just already mentioned it. So before that, first what happened? As I have already told that we have to create a node. We have to create a node which consists of two parts. First part is to store the data. Second part is used to store the address of next node. So in this case, first we have to write down structure node. In C we know that by help of the structure only we can able to declare. So first we want to store the data, that's why I make the integer data. Then next is a pointer. Which type of pointer? Structure node type pointer, so we have to make the structure node pointer. Next, the pointer name is the next. So this is the declaration of the structure node. As I have already told, we require two pointers, structure node, two pointer, that is the start equal to null value. Then same structure pointer we want, that is the last also. We want last also pointer. So last store the value of null initialization. During the program, we also required new pointer, new node to store the newly created node value. So new node. In between also we require temporary to store the address of start node. Also one more pointer you require, that is to traversing PTR. So these are the three nodes we require. So we initialize the start as last as a null. So in this program, we have to first write down how to insert a function. So this function name insert first. The function does not takes any value, does not return value. So whatever data we enter, I store in the num. So I just make the num. So printf, enter the element into element to be insert scanf %d and percent num. We have to read the value. Once we read the value, then what is the next step? We have to allocate the memory. Once the allocation is done, we have to store into the newly created node. So new node, this is the malloc function. We have to call the malloc function. Malloc, we don't know how much memory required, so we have to use the size of operator to calculate. Then here we have to check whether the memory allocation done or not. So we have to check if new node equal to null, means memory allocation is not possible. Then what we have to do? We have to printf we have to write down printf insertion not possible because we cannot able to insert the data. Then exit 0. This is for the memory allocation is not possible. If the memory allocation is possible, then what we have to do? We have to insert the value. So now we have to check first condition. We have to check linked list is are empty or not. What is the condition? If start equal to last and start equal to null, then it is empty list. If it is an empty list, then what are the operation we have to make? We have to make start equal to last equal to new node. So new node we make as the start as well as the last one. Then start data. We have to store the num value, whatever value enter. Then start next. Next equal to null because it is only single node right now. So these three statement we have to at a time we have to perform. So here within the curly bracket we have to store all the information. So after that this is the case for if it is a empty list. Else means elements are present. So what we have to make? First statement we have to store the temp equal to start. Then next statement we have to follow, that is now initially store the value new no node as a start. Then what happen? New. Then we have to make the start equal to new node. Then start data store the value of newly enter value. Then start next. Start next. Now you should point to the remaining part of the linked list. Remaining part of the linked list right now stored inside the temp variable. So these are the statement we have to follow whenever linked list has the sum of element. So this is the insertion part. So once insertion is over, then what we have to do? This is the else part. This is the ending parenthesis for the. This is the ending parenthesis for the. So this is our void insert code. So once we write down the void insert, next question. After insertion, we want to print the value or not. Next, we have to learn how to print the value. So, for example, this is the node is already present. We have to print only. Let three element is present. So, first element is 10, 20, 30. This is our start node. This is our last node. So, this is the pointer. Now, this is the 100 address. So, start store the 100 address. Second node is the 200. So, you store the 200. Third is the 300. Linked list is established. This is the null. Our output we want to print. This is the start, one arrow, then the first data, then second data, then third data, then null. So this is the representation we want. So now we have to think what is the possibilities we have to do. So start arrow, then this is the comma, this is common, this is common. So first we have to print this value, then we have to use a for loop. As start node store the address of all the remaining elements, so in this case we cannot able to use the start. Always we have to use another pointer that points the address of start. So here what we have to do? We have to make a ptr is a pointer, we store the starting address. Before that, this thing we have to print. So what we have to write down? Printf new line starts. So just write down, we have to perform here only. So void so we have to first write down printf new line start. So it will right now it prints this value. Then what we have to do? We have to use a for loop. So for ptr equal to start We have to start from PTR right now points to this one to end. End means PTR not equal to null. This is the termination. This is the null value. Then next iteration means PTR equal to PTR next. So PTR equal to PTR next. So this should be our loop. So we have to use a for loop. So for PTR equal to start pointer initialization, then PTR not equal to null, then PTR equal to PTR next. So it will go by one more. What is our objective? Our objective, it should print the, during printing, what it should be print? It should be the data value. So here we can write down %. This is the arrow. So according to that, output will be displayed. So printf %d, one arrow. Then what information it is going to print? We have to print the data. Then once the for loop is over, then what happened? Up to this we print. Then what we have to print? We have to print the null value. So after that we have to write down printf null. After that our void function, that is the our display function is over. So once display function is over, so in this program we write down how to print the value, how to insert the value, then we have to go to the main. So main, we have to write down void main. In main function, what we have to do? We have to only call the function. Insert fast. Second, two times we are in this program. I'm just using it. That's why in linked list we require the menu drive program. For example, I enter value 10, then I enter value 20. So it will be display the value 10 before the 20 is inserted. Because here what happen, insertion in the first position. For example, we want to insert 4 times. So it will be insert 4 elements. 10, 20, 30, 40. So 10 is the starting node. After that we insert the first position 20. After that we insert the 30 first position. Then 40. So this is the output. So in this case, in main program, we call the insert fast function 4 times to execute the program 4 times, or insert the value for 4 times. To solve this problem means we don't have to write the code multiple times. We can go for the menu drive program. This is the advantage of menu drive program. So we can go for the menu drive program. This is our menu drive program. Here same function is present, only inside the main we have to write down printf, enter the option, you have to enter the choice. In this menu drive program I only take two case, that is 1 and 2. For 1 is for insertion, 2 is for display. So that's why it is case 1, case 2 is present, then default. So in this case we can able to run the program for only insert and ls display. So it will ask me that, so I enter 1. So I enter 40 first value. Yes, I want to insert at node first position. Yes. Then which value? Okay, I want right now that is 30. Yes. 1, 20, Then, yes. Now I want to display. So for display, I have to enter. So it will display the linked list, that is 10, 20, 30. So do you want to continue now? So it will back to the our main program. This is the advantage of using the menu drive program. So first we have to understand how we are performing the operation. Then only it is better we should go for the menu drive program. So this is our complete program. Thanks for watching my video. Please like, share and subscribe the channel.